All right. 10 o'clock by my watch. I think we have quite a few folks here, some folks trickling in. But to be fair to those who were here bright and early, we'll get going. Before I get started, I have a question for all of you. How quickly do you need to detect a failure? Before the client detects it, before it happens. I'll give you a couple of examples. First of all, how many of you think that if I can detect a failure in 1 minute, it's pretty good, 1 minute or better? 2, 3, 4, 5, few folks in the room. Wow, okay, you guys are not too hardcore. All right. How about 1 second, 1 second or below, sub-second failure detection? Okay. All right, we have more hands. Okay, now it's getting exciting. How about 150 milliseconds? This is a popular one. 150 millisecond or below. Okay, so a few more. Tighter SLAs I can see. Okay, 150 millisecond. Last one. How about, you know what, I don't care how fast, but crank all the possible timers. Put all the possible knobs, every single feature that I'll be discussing today, and make it as fast as you humanly possibly can. Anybody thinks this way? Wow, okay. Usually I get like 2 or 3 hands. I see like 4 or 5, okay? So maybe that's a good idea, or maybe not. But keep this in mind as we talk about data center network failure detection. So good morning, everybody. My name is Arkady Shapiro. I'm a manager of technical marketing for the Nexus 5K, 7K, and 2K. And before I got to this role, I spent about 3 years as a technical marketing engineer, primarily focusing on layer 3, MPLS, platform scalability, fast convergence. And in my current role, besides managing several folks on the technical marketing team, I focus on platform architecture, also platform scalability, and failure detection. Among many things that come on the failure detection is BFD, bidirectional forwarding detection. So if you don't know about it, you will learn about it very soon. We'll spend a lot of time on it, about 50% of the session. I spend a lot of time on it as well. In fact, my colleagues, many of them are here in the room, they usually tell me that I'm pretty obsessed with BFD. Okay? Now, that may be true because now my wife, who is technical, but she's not a networking person, she knows about BFD as well. Okay? And my daughter, who's 4 years old, she knows about BFD too, because she drew that. So she's practicing writing. I kind of had her like, hey, why don't you write me some letters? And I say, well, what could you possibly write? You could write BFD, right? So yeah, you can say that I'm obsessed about BFD, but I think it's pretty important. I like working on this technology. I like kind of finding all the possible caveats and best practices and sharing it with all of you guys. So let's get going. Before we look at the agenda, a couple of goals for today. First of all, we'll try to understand where failure detection fits in achieving the overall network convergence. Now, some people think that fast convergence is just tuning a bunch of timers, maybe some hello timers, maybe some LSA timers. It's a little bit more than that, right? But the failure detection is an important part, and we'll try to understand its importance, and we'll try to see why it's so important. Okay? Next thing, some aspects of failure detection as it pertains to data center. Now, as I was talking to customers this week, many of you, some of you may be coming from enterprise to data center. Or you may be coming from service provider to data center. I just had to meet the engineer for a customer who said, hey, my colleague who managed those Nexus switches left. And now I have to deal with that. Oh my God, I'm so freaked out. What am I going to do? Okay, so now you have to think. Everything that you've been learning with your Catalyst switches or your CRS routers, does that still apply to Nexus, right? This is a data center session. We'll be primarily talking about Nexus with a little bit about iOS and iOS XR, right? But mostly Nexus. Okay, so you have to keep that in mind. Some things apply, some things you have to rethink, right? Even if Cisco's been telling you something for 20 years, do this, do this, do this, right? You may have to rethink that. SLAs. What do you need to do to achieve your SLAs? Some of you have very tight SLA. Those of you who raised their hand when I said crank every possible timer, Well, you must have very tight SLAs, right? Or you just like switches that much, you like to configure every knob, right? But let's say that you have very tight SLAs. So maybe you do need to use every single feature that we'll discuss today, every single knob. Maybe you will not need to use anything. Maybe you walk out of this room and you'll tell me, you know what, I had this feature configured, I'm actually going to remove it because I don't need it. It's just creating complexity in my network, okay? If you do that, if you come out with that realization, I would consider my job done. So that's something to think about. Last thing, we'll talk about some advances in the failure detection technologies. Okay, so we won't talk too much about roadmap, but we'll talk about where industry is going and how we're trying to solve some of the problems that still exist in the failure detection today. We've solved quite a few, but there's still a few things that are open on the table. Now, I only got 90 minutes. There's a lot of stuff to cover. So to get us on the same page, few non-goals for the session. First of all, I will really focus on failure detection. There are some other sessions this week that talked about the overall fast convergence. Yesterday, there was a session by Denise Fishburne. She covered the entire gamut of fast convergence, right? Detection, convergence, propagation, route programming, the whole thing, right? But typically, we don't spend enough time looking at failure detection. And I keep getting those questions from customers about UDLD, about BFD. So that is why I decided to do the session. That is why I've been doing this session for the past couple of years. Right? Usually, folks keep coming in because they keep wanting to learn about that specific aspect of fast convergence. Okay? Next one, who likes SDN? Whatever you think SDN may be. Few people. Okay, so those of you who like SDN, you might be saying, hey, I could build my own failure detection mechanism. Okay, so I can write a script. The script will be doing pings, and based on the ping results, I will interpret those results, and I could try to shut down the link if I lose so many pings. Yeah, you could do that. But let's take a look at what we already have on the switch today. Okay? And if that's not enough, then we'll give you Python scripts, NX API. NX API is one of the programmability features that we have coming up on the Nexus switches, if you haven't heard. But first, right, what do we have on the switches today? We won't focus too much on troubleshooting. If you're worried about why is my CPU high, why am I getting bursts, why do I have high latency, won't be talking too much about that. Okay. Things like trace routes, pings, right? The gentleman earlier asked me about trace route, and specifically layer 2 trace route. Right? So I try to focus on things that are kind of a network self-healing, right? Like BFD, UDLD, that does not require user intervention. Right? If I have a problem, I will detect it right away. Okay? And we'll focus on what we're shipping today with a few exceptions. There's a new release that we have coming up. Hopefully it will ship this week, maybe next week, NXOS 7.2. So I'll be making some references towards that. But other than that, we won't be going like 6 months to 1 year roadmap, right? This is really what can you do today, all right? So with that, here's the plan for today. We'll have a quick overview, and we'll follow an OSI model. I trust most of you are networking folks. You like OSI model. It helps us talk about networking. So we'll talk about layer 1. We'll talk about layer 2, layer 3 failure detection, and some additional mechanisms that we have on our Nexus platforms, okay, that don't really fall into one layer or another. All right? Sounds like a plan? Any questions? Very good. So let's get going. This is a very simple CCNA type example. What happens when we have a network convergence? Routing convergence in action. So imagine I have this network, 3 routers. I have a failure. Well, packets start dropping, right? The failure happened at time t0. Now, at time t1, I actually detected the failure. Okay, that's good. At time t2, I actually start propagating this failure. I tell my neighbors that something happened. And then at time t3, the other neighbors kind of figure out, they try to recalculate, and they learn about this failure and try to decide what do they do about it. Do they have to go another path, or do they just stay on the same path? And then time t4, everything with convergence, your total loss of connectivity is from beginning to the end, right? T0 to T4. But What we're focusing today is the failure detection, which is from time t0 to time t1. As I said, other topics, right? Failure propagation. Some of you may have tuned LSA timers, throttle timers for OSPF and whatnot. Topology recalculation kind of falls in this area, what we will not be discussing. Route programming. How many of you know BGP pick? Have like 3, 4 hands, 5 hands? Okay, so a few advanced folks maybe know BGP pick. Right? So BGP pick, prefix independent convergence, really has to do with how quickly can I program my forwarding table. If I have 100,000 routes that changed, can I send one update instead of 100,000? Right? That is BGP pick. Right? But back to failure detection. Failure detection is a very critical topic, and it's also pretty challenging. I mean, that's one of the reasons why we have this session. And the reason that it's challenging is because you got a lot of things to think about. Okay? A lot of layers, as we discussed before, to consider and debate, do we need to do something or not? Do we tweak layer 1? Do we tweak layer 2? Do we do all of them? So that's the question, right? Do you really need to touch all of them, depending on your SLA? Some of you do. Some of you may need to touch only one. Some of you may not need to do anything at all. Now, once we decide what we need to touch, then we have to look at the specific tools. And the tools that you see here in each of the layers, the things that are in yellow, are the things that we'll be discussing. Right, so there's some additional things that I won't cover. But particularly on layer 1, remote fault indication, signal propagation. Layer 2, UDOD, LACP. Why is he talking about UDOD in 2015? My God, I thought I should know about this already. Okay, well, think again. You will see soon. Aggressive timers, right? Do we do timers, or do we tune timers, or do we use BFD? By now, you've probably figured out what is my stance on this. Okay? If you haven't figured it out, you'll know very, very soon. And finally, we'll touch a little bit on IPSLA, okay, as it pertains to some very specific point-to-point data center failure detection scenarios. Okay? So we're diving in. Interconnection options. How do we interconnect devices in a network? Right? This applies to data centers, this applies to enterprise networks as well. Now, first case, you have 2 routers, layer 3 connection, point-to-point, nothing in the middle. Chances are that a failure will be detected very quickly. Right? I don't need to have any additional mechanism here. If a link goes down, then I can detect it right away. Interrupt-driven detection. Most modern devices, switches, routers, they can do interrupt-driven detection. So that's easy, right? There's always exceptions to this, but by and large, typically folks do not need to do anything extra over here. How about this? What if you have a bump in the wire? You have an optical system in the middle. What do you do then? If something happens in the optical system, what is the chance that that failure is going to get propagated to the other end? Maybe it will be, maybe it won't. But you need to have some mechanism to ensure that that failure gets detected. Okay? So this is where we start thinking about the layer 2 mechanisms. Other things. Layer 2 bump in the wire. How about that? Okay, so now you definitely need to have something, right? Something either tuning timers or using BFD, bidirectional forwarding detection. Okay? Because you got a switch in the middle. If I go unconfigure a VLAN on the switch, what happens? Normally, you just wait for your OSPF timeout, and you wait and wait and wait, and 40 seconds. Those of you who like sub-second, sub-150 millisecond, or cry every single timer, not good, right? Last case, layer 3 bump in the wire. This is the case of having a routed firewall and NAT device that decrements CTL in between the 2 routers. Okay, so that's also where I need something like multi-hop BFD, or something else like IPSLA. Okay, so we'll take a look at that towards the end of the session. As I talk to customers about their data center requirements, and I try to translate them to failure detection, a few things come up usually. First thing is folks want fast convergence. So many of you raised their hand, right? You wanted sub-second, sub-150 milliseconds. You want fast convergence. And what this means is you want a sub-second failure detection. Those of you who did not want fast convergence, who did not want it to be sub-second before, and if you're thinking about migrating to 40 gig or 100 gig, you might start thinking about it now. Because one of the customers told me, he said, hey, if you make me move to 40 gig, but your convergence characteristics is exactly the same, well, now you've just affected that much more traffic, right? So the same thinking cannot apply when you move to 40 gig and 100 gig. If you didn't care about convergence before, you probably might have to care about it now, okay? One aspect, path isolation or link isolation. Some technologies, they kind of say, hey, something failed, and bye-bye, right? Keep sending packets to it. You Mr. Network Admin, you go figure out what you want to do. We don't like that in a data center. I don't like that. I like the stuff that actually detects and isolates the path. So you have to think about that. Is the tool or technology that I'm talking about isolates the path, right? Some do, some do not. And there are some caveats in the middle. Density. Any of you have seen Nexus 7700s on the World of Solutions? Okay. How about Nexus 9500s? Okay. We got some dense switches there, right? Lots of ports, up to 768 10 gig ports on the 7700. Okay, so if you have all these ports, that means lots of sessions, lots of protocol sessions, lots of BFD sessions. Okay? So you need to think about which platform can scale to all these sessions. And that's just physical ports. What about if you're doing multi-tenancy? If you're doing PEC routing, and you have thousands of subinterfaces, each one of them needs a BFD session. Which platform can scale to this many sessions? What does the platform need to do to be able to scale to this many sessions? Again, some platforms do and some platforms do not. So when you select the platform for your data center, this is something to consider, right? And protocol offload, we'll talk about that. This is an important characteristic of that. This is how do we achieve scale, particularly in the case of BFD and OAM. Okay? HA, who likes ISSU? Oh, like about half of the room. Great. Okay. So those of you who like ISSU, you need to worry about that. And you need to make sure that my failure detection mechanism supports ISSU. Not everything does. If you go tune OSPF timers, it's not going to work. If you go tune LSA timers were okay. But LACP timers, not going to work. Again, something to think about. Those of you who don't care about ISSU, you have to think about, does my failure detection protocol allow me to isolate the switch gracefully from the network? BFD can do it pretty well. Other mechanisms, maybe not so well, right? Something to consider. Link aggregation. We'll talk about some caveats with respect to bundles, link aggregation as it pertains to BFD. ECMP, this kind of goes back to scale, right? Can I have wide ECMP? Can I build a data center fabric, right, what we sometimes call standalone fabric, and run a failure detection mechanism on all those links, and on different types of links, right? Bundles, point-to-point links, layer 2, layer 3, and whatnot. And the last thing, it's got to be simple, right? I don't like to have 20 different features. I don't want to sell you 20 different features if you can use one, right? I like to keep things simple. I keep looking at customer configs, and customers sometimes just really, really crazy things. And I say, why do you need this? Why do you need that? I have one feature that can do it all. Right? So if I was a sales guy, I probably would sell you like 50 different features. But I try to make your life simple. So we'll be talking about that. So back to our original question, right? Some approaches from the enterprise or from service provider may apply to data center. Some may not, right? So we'll be looking to that, and I'll be referring to specific scenarios where things may apply and where you have to change your thinking. Right? You have to change how you think. Okay? So reference topology. So I have a couple of reference topologies of typical data center deployments. Why am I showing you this? Well, it's because we'll be referring to those topologies throughout the session, right? which mechanism, which knob, which feature applies in each of those scenarios. First thing, VPC. Vast majority of our customers implement VPC. We had 460 people in the VPC breakout session this week. That should tell you something. Okay? So with VPC, we have some Nexus 7Ks there. We might have some access switches, 5K, 6K, 9300s, multi-chassis ether channels, bundles, layer 3 uplinks, point-to-point links, bundles, connecting to routers. You see that router icon up on the top. Maybe a Cisco router, maybe not a Cisco router. Hopefully a Cisco router. But in some cases, we have customers, other vendors, we try to interoperate. Okay? So that's VPC. We got some firewalls there, maybe transparent firewall. How do I detect a failure for traffic going through that firewall? Okay, remember our case of bump in the wire earlier in the slides. Okay, something to consider. Fabric path. Who's got fabric path? Who's got it deployed? All right, but like a third of the room. So we've been seeing a pretty good adoption of fabric path. Okay, so what do we do with fabric path? Well, we throw out that whole VPC stuff. We just leave it at the access. And now we have ECMP, layer 2 ECMP in the fabric. So you see all those green links, equal class multipathing. Okay, so we need to think about, hey, well, what is the protocol there that allows me to detect a failure? Okay, uplinks are very similar, right? Your layer 3 uplinks, you have to get to the outside world, so nothing different here. Okay, so that's fabric path. How about this? Who's heard about standalone fabric this week? One person heard about it. The rest of you have not. Okay. We've been talking about standalone fabric, and essentially, if you have fabric path, what we can do is take layer 2, layer 3 boundary from the aggregation to the leaf. No HSRP, none of those protocols. And give you an overlay control plane protocol, such as BGP for host reachability. Okay, so the network becomes from a pure layer 2 network to an integrated layer 2/layer 3. You don't have to think about, okay, is my network layer 2? Do I need to run routing protocol on top of this network, do some peering, and do some crazy things like that? Those things are gone, right? So we've been talking a lot about standalone fabric concept this week, and I'll be touching on this a little bit, but I'm happy to address any questions that you may have. Okay. Okay, and then that standalone fabric can have fabric path as a base, or it can have VXLAN as a base, right? So the red links are layer 3. That's a layer 3 underlay, VXLAN, right? Green links are fabric path links, layer 2 underlay. Okay. By the way, I'm happy to take any questions, so feel free to ask them live. There's also a question manager that I have that is ready to answer your questions if you want to ask the questions on the QM tool. And after the session, I'll be here or in the World of Solutions, so we can talk as well. Right? So drilling down specific scenarios. By the end of this session, we will learn what we need to do where. We'll talk about bundles, or layer 2 Ethernet, point-to-point links, bundles. Fabric path, point-to-point links, bundles. Layer 3, all those different scenarios. Do you use timers? Do you tune timers? Do you do BFD? Okay, so we'll have a recommendation by the end of this session. Okay, all those different scenarios that may come up in the data center. So, any questions up until now? Good? Let's start with layer 1. So when we have layer 1 failure detection, if I have a common link of 2 fibers, if both of the fibers fail, that's easy. Interrupt-driven failure detection, the link goes down pretty quickly. I don't need to have any other mechanism. How about if just one fiber fails? What do? In the good old days, we used to use UDOD for that, right? Because we said, hey, one fiber fails, I need to make sure that I can detect this as a unidirectional failure. Don't need to do that anymore. Modern protocols, 1 gig, 10 gig, 40 gig, 100 gig, they all support this. Our X-link goes down, I signify on the transmit to bring down the entire link. Okay? So that's easy. It's already built in. There's no knobs, there's no timers, there's nothing to crank or tweak. It's already there in all your switches that do 1 gig, 10 gig, 40 gig, 100 gig. Okay? How about this scenario? Remember my bump in the wire? Keep talking about this bump in the wire, right? If you have an optical system in between, And if you have a failure on one end, is that going to get propagated to the other end? How many of you think yes, it will? It depends, exactly. So the gentleman said, it depends. Yeah, you're right, it depends. It depends on who's managing your optical system. Are you friends with them? Maybe you're not friends. Maybe you're like, okay, I don't want to touch this thing. So then you can't trust the guy. You can't trust the guy. You can't trust the box. So you, as the person who's managing the two endpoints, need to do something yourself. Right? You need to think of another mechanism. So maybe this will be a layer 2 mechanism, such as UDOD, or maybe this will be a layer 3 mechanism, such as BFD. Okay? We have a couple of timers that we have on the layer 1, things that essentially delay the link down notification. First thing is carrier delay. How many folks heard about carrier delay? Okay, I got some hands up. Okay. So carrier delay is a timer that we have primarily on our routing platforms, right? So not so much on the Nexus and the Ethernet switching kind of ports. Right? Delays link up notifications and link down notifications. Okay, so there's some fixed values. Typically, we have fixed value of 100 millisecond. On the Nexus switches, we support it only on the SVI. So guess what? If we only do it on the SVI, we don't recommend to tune it down because we want to allow the layer 2 network to reconverge before we bring down the entire SVI. Right? If all the layer 2 ports are down, the SVI goes down. Right? But if you have routing platforms on point-to-point links, you may be able to tune this. Again, this is done to prevent flaps. Right? If you have momentary flaps, trade-off, right? If you can bring this up, you can absorb more flaps. But then you're blackholing more traffic. Okay? So your choice, right? As long as you do it carefully, right? But don't mess with this. Leave it at default. If you try to mess with it, do it with a purpose. This one, debounce timer, is something that you'll see more commonly on your data center switches. So on Nexus, we have a debounce timer. It delays just the link down notification. 100 millisecond by default. You can tune this. Again, same consideration. Right off the bat, I usually tell customers, let it be. Let it be as a safeguard for you. But you may want to tune this. I've had one customer who had a very tight SLA, sub 200 milliseconds. And they cranked and tuned every possible thing. This is the only thing that allowed them to go below 200 millisecond failure detection and overall convergence. Okay? But they knew the risks, right? So I told them, I said, hey, if you have momentary flaps, it might be too aggressive for you. They said, you know what, my link quality is good. I trust this link. I really need to do this. So, okay, as long as you understand and you understand the risks, then that's okay. Right? So what do you do? Which one do you need to worry about? In a data center, most of the time, it will be the debounce timer. Right? On your switching platforms, on the routing platforms with a switch module, right? We have some ISRs that have a switching module that go inside them, right? Maybe at the edge of your data center. That is where you have debounce timers. Okay? So it can be tuned, but by default, better not start tuning it right away. Right? Make sure you test it. Very common approach. Okay? So that's it for layer 1. Sounds good? Not too many things here. Okay. So before we get going with layer 2, I'm going to say something shocking. Well, maybe it's not as shocking to you now that I've mentioned it a couple of times. I will tell you that UDOD is practically useless for a modern data center. How many of you find that shocking? Everybody agrees with me? No kidding. We'll talk about that. Well, the gentleman says, well, there's a white paper that talks about UDOD with BFD on the Nexus 7K. We'll discuss after the session. I'd like to take a look. So the rest of you agree with me? Wow. I've managed to convince some folks before I even dive deep. Yes, sir. Okay, so the gentleman is saying it could be a problem with broken transceiver. It's not detected, so that's why he's saying you need to use UDOD. Okay. So one person doesn't agree with me at least. No, that's fine. I want to see. This is interesting. Okay, so most of the room seems to agree with me. But for those of you who do not agree, let me explain why I think this way, why I keep bashing UDOD. I mean, Cisco's been telling you for, 20 years, use UDOD. Every single document says use UDOD. Every single AS engineer who goes into your site, they do a network scan, and they usually say, oh, you don't have UDOD enabled. Put it in. They don't even think. I keep running into this every single day. So some thinking has to change, right? Remember I said, thinking from the enterprise going to data center. Do we still need to do this? Okay? So let's take a look why. Quick reminder on UDOD, right? Was designed by Cisco, lightweight protocol, detects two things, right? Unidirectional failure, one-way connections, and also miswiring. We'll talk about what miswiring is. And UDOD is pretty slow. 7-second interval, up to 90 seconds. Typically, we have 15 seconds as a default interval. So by the time we detect a failure, yeah, it will take a while. For most of you who raised their hands, who wanted sub-second, it's not going to fly. Remember, guys, this was designed in, the 90s, right? When we did not have 10 gig or 40 gig or 100 gig, right? So back then, this was kind of okay. Not okay now, all right? Case number one for UDOD, empty echo. So UDOD builds on a principle that I know about my neighbor, and my neighbor knows about me, and I keep getting packets with my information from my neighbor. So if I have a failure on one of the fibers, my switch B on the right-hand side stops receiving packets. It times out. It clears switch A's information from the table and starts sending empty echo. I just know about me, I don't know about you. So when switch A receives empty echo, what does it do? It error disables the link. This is known as UDOD normal mode. Okay? Case number one. Now case number two, miswiring. Here's a scenario. Switch A, fiber connect to switch B, then fiber connect to switch C, and then fiber connect back to switch A. Miscabling. How many of you think this can happen in your data center? Yes or no? Oh, wow. This is like the most hands that I've ever got. That's like about 10 people. But for the rest of you, not possible, unlikely, right? Why do I think it's unlikely? Well, modern data centers, we have LC connectors, usually transmit and receive stuck together. Less of a chance of having this kind of scenario from happening. But again, not impossible, right? This is one case that UDOD helps with really, really well. Okay, so keep this in mind. For those of you who think that this is a possibility in your data center, this is something to remember. Park UDOD for a second. Bridge assurance. So what does bridge assurance do? Turns spanning tree into bidirectional protocol. Before spanning tree was unidirectional. Now I make it into bidirectional. Well, what happens? That's great, right? Because now I have a failure detection mechanism. Maybe I don't need to rely on UDOD anymore. Okay? So this is an example of the spanning tree bridge assurance that we've enabled. And it has detected a link. If it stops receiving BPDUs, it puts the port in bridge assurance in consistent state. This is path isolation. Remember I talked about path isolation in the beginning. If my protocol cannot isolate my path, no good. Okay? So a couple of caveats for the bridge assurance here, right? Not recommended on VPC member ports. Doesn't work with ISSU, except if you do it on the peer link, VPC peer link. Okay? But it's a good thing to have. By now, Nexus switches, iOS switches, they all should have it. Right? We started with this on the Nexus, but it's proliferated to iOS as well now. Okay? So how does this work? Bridge assurance, or before the bridge assurance, we just got BPDUs going in one direction. When we enable the bridge assurance and put the port type in network mode, now I have it in both directions. Okay, like I discussed. I have a malfunctioning switch. I stop receiving BPDUs. I put the port in bridge assurance in consistent state. Okay, very simple. Very good feature to use. Right? Not on your VPC member ports, but on your VPC peer link, and anywhere where you have just a pure layer 2 spanning tree link. Okay? LACP. Why am I talking about LACP? So LACP is a protocol that we use in the bundles. We use it for a couple of things, config consistency check, but the most important one that I'll be talking about today is the keep alives and the detection of unidirectional links. If you haven't figured it out by now, LACP is a failure detection protocol. It's not just for the config consistency checks. Okay? So typically, if you lose the heartbeat, you're supposed to isolate the link. If you implement LACP properly, you do LACP suspend. With one little caveat, right? So if you have Nexus 5K, 6K switches, by default, they actually do not isolate the link, right? Because they've been designed as an access switches. 2 access switches, we connect servers that may be doing FCOE boot, NFS boot, Pixie boot. So if I do that, I need to be able to bring up the link before I have LACP running. Okay? But if you connect those ports to real switches, then you need to change this value, right? You need to change it to this. Default is no suspend. Now you need to change it to suspend. Okay, this is a per interface configuration. Okay. Now LACP is pretty slow. Was it 30-second interval, 90-second timeout? No good. But it is what it is. You can tune it to another fixed value, to 1-second interval, but very much not recommended. Why that's not recommended? ISSU. So those of you who liked ISSU earlier, who raised their hands, no good. Why it doesn't work with ISSU? ISSU takes some time. It takes time to bring up the standby supervisor. If we have aggressive timers, we won't be able to bring it up in time. You have false positives, no good. Okay? So if you care about ISSU, this is not going to work. How do you ensure that you have long timers, that you have 30 seconds? There's one little problem with LACP. It does not negotiate the same value. If I configure a 30-second interval on one end, and the other end is 1 second, the other end, by the way, may not be controlled by you. I've had network guys, and they connect storage filers to their switches. The storage filer is, of course, controlled by their SAN guy, NFS filer. And they go, OK, well, the SAN thing is running 1 second. LACP does nothing about it. We start sending 1 second interval back. Next time the network guy wants to do ISSU, broken. OK? So this is not Cisco. This is just how LACP is designed. You can talk to IEEE to get this fixed, right? But this is really IEEE standard. LACP does not do any of those things. So coming back to UDOD, I'm not done with it yet. I'm not done bashing it, right? So here's some original deployment scenarios for UDOD. If you look at the functional specification from our engineering, I think this is back from the 90s or something like that. Here's some things that they thought of. They were going to design UDOD, new Cisco proprietary protocol. What problems are we trying to solve? First thing, spanning tree loop prevention. So if I stop receiving spanning tree BPDUs, I want to isolate that link. I wanted to use UDOD. In 2015, not relevant anymore. Your modern spanning tree protocols, they can detect a failure much faster. 2-second interval, timeout is 2 seconds times 3, or the max age of 20 seconds. It's going to be way faster than your UDOD timeout values. Not needed. Doesn't do you anything extra. Okay? How about this one, right? Spanning tree convergence, the BPDUs in the other direction. We have bridge assurance now with the same timeout values, right? We're sending the same BPDUs, but we're just sending them in both directions. Okay? So if you have bridge assurance, UDOD doesn't apply there either. How about bundles? Anybody has a problem running on LACP today? Anybody has to do mode on a switch-to-switch links? Nobody. Okay, one person. Say it again? Okay, certain hosts, yes, but at least on the switch-to-switch links, no problem. Okay, so the gentleman's saying, yeah, I might have a problem doing it on the host-facing links, right? But on switch-to-switch, I have a problem. But anyways, to the host, you won't be running UDOD, right? So on the switch-to-switch links, everybody has no problem doing LACP. So this doesn't apply either. Back in the day, people were like, okay, some switch doesn't support LACP, or I can only do mode on. Doesn't apply anymore. We're in 2015, right? Modern days. Okay? So to summarize, do you still need UDOD? Yes, sir. So the question, sure. So the question is, with the mode on, does UDOD still apply for 7Ks with FEX? It depends on which links, right? On the FEX down links, you're not going to do it because you don't have a switch connected to them. Now, hold that question till the end of the session. I have a scenario about the fabric ports, and I'll talk about the failure detection mechanisms that we have on the fabric ports. Short answer is we don't have UDOD there, okay? So it's only on switch-to-switch links, okay? But good, thank you. All right, so how much do you really need UDOD? Unidirectional failure on layer 1. Remember one of the first slides on layer 1 we talked about. 1 gig, 10 gig, 40 gig takes care of it, done. Layer 2, bridge assurance. Takes care of those failures as well on the layer 2 link. Stuff that couldn't have been detected by layer 1, right? Just a physical fiber failure. LACP. We've got LACP. We can use that to account for bundle member failures. Now, you might be arguing with me and saying, well, okay, LACP is like 90 seconds, and UDOD may be a little bit faster, what, 45 seconds? My argument to this would be, in the spirit of simplicity, I prefer to have one protocol. If your convergence is already this slow, chances are that your applications have already timed out. Okay, so going from 90 seconds to like 50 seconds. If that buys you something, great. For many customers that I talk to, it doesn't buy them anything. It's already like way past their SLAs. Okay, so that's why I keep saying, hey, your LACP is already there. What else are you trying to do? Miswiring. In most of my customer audiences, I have less people raise their hands. So here we actually had quite a few folks. But most of the folks that I talk to usually say that that miswiring scenario, that triangle topology, is not likely in their data center. If it is likely, then yes, this is one case that UDOD does help with, right? That the other technologies cannot take care of. But if you don't, that doesn't apply to you, right? Layer 3 links and fabric path, we already have a bidirectional protocol running there. UDOD doesn't do anything extra either. UDOD will time out in, what, like 45 seconds. OSPF, ISIS will time out in about 40 seconds without any BFD, without tuning any timers. Again, doesn't help you that much either. Now, if you still got to use it, UDOD, for some of those scenarios, miswiring detection, just keep this in mind, right? Normal mode and use default timers. Yes? So the question is, I don't recommend aggressive mode. Yes, that is true. We recommend normal mode because aggressive, especially given the fact that UDOD runs on the supervisor, we try to make sure that there's no false positives. And with aggressive mode, we've seen some cases where we can have some false positives. So we try not to do that. After all, right, some protocols, they just isolate the link. UDOD shuts it down. How bad that would be in your data center. If you guys want to hear more about what can happen when UDOD shuts down links, there's a session later on at 3 o'clock that talks about securing Nexus devices and hardening Nexus devices. So you'll see what can happen, but I'm just giving you a little preview. Okay? Very good. Does that answer your question? Good? Thank you. So, one more thing. Are we clear on UDOD? Even if you don't agree with me, at least you understand where I'm coming from, hopefully. Okay? Very good. Last thing for layer 2, Link OEM. Why am I talking about Link OEM? Who's heard about Link OEM? Who's in the SPI guy here? Okay, one person, just one. Okay, good. So maybe a good discussion for data center. This thing comes from the carrier vault. It comes from service providers. Primarily deployed on 7600s, ASR9K, CRSs. It's been originally designed as a slow protocol, not as slow as UDOD and LACP, but standard defines the minimum value of the hello interval as 1 second. In Cisco, we've done something better. We do 100 milliseconds on specific platforms on CRS and ASR9K. Okay? So it's a very extensible and flexible protocol that gives us some interesting capabilities for failure detection. 2 functions of Link OEM, right, specified in the 802.3 AH. One thing is the discovery, right? So I can learn about my neighbor learns about me. If I stop receiving packets from my neighbor, I consider that a failure, and I can do something about it. Right? Remember our path isolation? right? I can do something about that failure. Link monitoring. Somebody said before, I want to detect the failure before the user sees it. Sometimes people tell me, I want to detect it before it happens. This is where this stuff applies. Okay, so we'll talk about this. And we're going to talk about this now. How coincidental. So link monitoring allows us to monitor the link every 1 second. We set some thresholds based on CRCs, frame errors, things like that. And based on reaching that threshold, we can do stuff. We can send a notification, or we can isolate the link. Okay? Here's one example of what might happen if you have supported platforms. We don't support it on Nexus today, but there is support on CRS, on ASR9Ks, on iOS devices. Okay? So what might happen in the future is that if you have a supported device at the aggregation layer, and you have a device at the access layer, which does cut-through switching. Cut-through switch, forward CRCs. Okay? Now the layer above can actually isolate that link if we have too many CRCs. Okay? If it goes above the threshold, right? So this is an example of monitoring for a threshold for a number of CRCs and isolating the link if I reach the threshold. Just doing error disable in this case. Okay? There's a couple of caveats with isolating links in Link OAM. There's many things that we can do. Unfortunately, there's no standard that really defines how this is supposed to be done, so this is implemented on a per platform basis. We can do many things, right? Once we detect a failure, we can isolate links. Well, first we do syslogs as an MP. We have a message that's being sent to a peer neighbor saying that, hey, I've detected a failure. But we can also error disable or error block, or something that's called EFD, Ethernet Failure Detection. I'll talk about that in the next slide. Okay? One thing to keep in mind is that the error disable for timeouts or the EFD, this is only available on iOS XR. Right? So with iOS, you typically can just send a notification, you can send SNMP, but you can not isolate the links on a timeout scenario. Right? So if I had a timeout, 1 second, I send hellos, up to 3 seconds, I stop receiving it, I cannot isolate the link. So the question is, does the other side of the link need to be iOS XR as well? Well, if you're isolating based on the timeout, yes. But if the only thing that you're doing is link monitoring, then no, because I can do link monitoring locally. It's just I cannot send a notification to the peer because the peer cannot understand it. Right? Because if I can send notification, then the peer can do something about it. But otherwise, I'm worried about isolation right now. I'm worried about taking down the link. And with that, I don't need to have my peer understand this. But for timeouts, of course, I do, because both of the sides need to speak the same thing, and both of the sides need to have the same behavior. Does that make sense? Yes. Mm-hmm. Yeah. Sure. So the question is, if I had an ASR connected to the Nexus, ASR would take down the link. Well, then it would physically take it down, right? So the link's down, right? That's just layer. After that, it's layer 1, right? Interrupt-driven detection will the failure will be propagated. Yeah. Okay. So we have error disable, but error disable is no good. I don't like error disable. The reason I don't like it is because it's non-deterministic. We typically have a timeout value, we disable the link, then we bring it up, and oh, the link's still bad. We'll bring it back down again, and it keep flapping and flapping and flapping. Anybody had that happen? Link flaps? Oh, yeah. You bet. I don't like that. No good. So we have this thing on the iOS XR called EFD. What it allows us to do is if I have detected a failure, if I've detected the timeout, for example, stop receiving the OAM PDUs from the peer, I can shut down my MAC layer. And I can propagate to my upper layer protocols, saying, hey, this link's going down. But guess what? The link's actually physically still up. We're still trying to send the OAM PDU packets, not the data plane packets, but the OAM packets, to see if we can recover. And once we recover, we can bring up the link fully. Right? So this makes it more deterministic, reduces the churn, things like that. Much, much better than doing error disable. So if you have that option, if you have supported platforms, then yes, you can use it. Right? All right. So is this ready for data center? I said Nexus doesn't support it. We have it on iOS with some caveats. We have it on iOS XR with a few more features that we've discussed. Will you use it? Now, in most cases, you'd still have to rely on the other layer 2 mechanisms, right? Whether you use the bridge assurance or UDLD or LACP, right? For the following reasons, right? The isolation is only on iOS XR, so those of you who don't have XR, unfortunately, that will not work. Any kind of isolation based on a timeout, whether it's error disable or Ethernet failure detection, okay? And the miswiring scenario, remember that triangle topology? OEM actually has a mechanism for that, but it's Cisco proprietary. It's only done on XR as well. Okay, so if that applies to you, you cannot take out UDLD for something faster that is Link OEM. Okay, but if you have supported platforms, particularly we have a lot of customers who put ASR9Ks and CRSs at the edge, right at the top of the data center, connecting to their service provider. Well, then you can use that. Right? You can take advantage of link monitoring for earlier detection of a failure. And definitely that would be a very good thing. Right? And hopefully, as we bring support to other switches in the network, other switches in the data center, you can keep bringing down the link OEM and keep taking advantage of those capabilities. Again, for link monitoring and for timeout detection. Okay? So that's a wrap for layer 2. Any questions? Does this make sense? Yes, sir.
Just a clarification on the recommendation against bridge assurance on LACP ports. Is it just because you have the LACP failure detection?
Sure. So let me see if I can rephrase that. Clarification on bridge assurance against VPC ports.
Oh, yeah.
Yeah, VPC member ports. Yeah. So first thing is we typically send the sparing true PDUs from one switch, or when we do pure switch on VPC, we can send it from 2 switches, but they may still get hashed to 1 downstream switch. So if I do bridge assurance on the VPC member ports, I have a potential of link isolation right away, depending on how the BPDUs get hashed. And as you rightfully mentioned, given the fact that we have LACP, we have already something to take care of those scenarios. Right? On the VPC, we have LACP running. Right? So one thing, you have something running. The other thing is that if you still decide to do it, you may face a problem. You may not, but you may face a problem. Okay, so that's the reason. Yeah, and it should be pretty well documented on config guides and things like that. I think I have a link later on in the slides. Okay. Any other questions? Okay, very good. By the way, I have a lot of hidden slides in the deck. There's some things that I'm not covering or additional details. So feel free to refer to them after that. Right. But of course, right, I really like your questions. Keep asking them. Layer 3, we're moving on to layer 3, my favorite thing. I may still need to do something. I've looked at layer 1, I've looked at layer 2. Now, what about this scenario? 2 routers, got some switches in the middle, got some firewalls. The firewall goes down, or I misconfigure a context. I'll wait and wait and wait and wait, and when is this going to happen? Oh, something happened a while ago. Okay, we don't like that. Again, majority of you have raised their hands. You want the very tight SLAs. We want something like this, right? If I have a failure, like this, right? That's a little better. So how do we achieve that in a layer 3 scenario? When you have bump in the wire, when you have a couple of layer 2 devices in the middle. First of all, back to my mantra earlier, do you need to do it? Do you not need to do it? How do we keep things simple? If you have a hops in the middle, then yes, something you have to consider. Layer 2 hops in between the layer 3 link. If you have concerns for protocol software failures, some people say, hey, well, I had the switch and it had OSPF running, but OSPF was not sending hellos, but it was still kind of there. It was in this weird corner case stuck state. Same goes for ASICs. I hear this sometimes from customers. Yeah, my ASIC was stuck. It wasn't forwarding packets, but the link was not brought down. Can this happen? Yes. Is that a corner case? Yes as well. Do you want to design your network around it? It depends. Some people who are very paranoid and who have had this scenario before, they don't want to hear it. They're like, come on, you have a point-to-point link. You're telling me don't do anything. No. I've had things before. I've had bad hardware. I've had bad ASICs. I'm still going to do BFD. I'm still going to crank all the timers. That's okay, as long as you understand why. Right? But remember, right, this is still a corner case. Okay? Now, when you may not need to do it, point-to-point links, right, chances of a unidirectional failure, much small than having a bump in the wire. Software redundancy. On the NXOS, we have this thing called sysmanager. It's a little process that monitors all components, allows it to send them some hellos, and if the component stops responding, we'll try to restart that component. Right? So if it's completely stacked, crashed, and whatnot, we'll try to restart it. This is the NXOS software architecture. Right? So we have some provisions to mitigate against those scenarios that you may have faced with your prior devices before. Again, back to the case. If you're coming from enterprise networking to a data center, right? Maybe you've faced some of those scenarios before. So we have some provisions on NXOS to take care of those. Right? Okay. FHRPs. If you're running them in active-active, they're all forwarding. Don't need to tune HSRP timers. Don't need to do BFD for them. You don't need to detect that an active HSRP router failed quicker. Okay? So we have protocols on the layer 3. We have OSPF, we have HSRP, we have BGP. They all use timers. They use them to exchange information, and they use them to detect a failure. Right? If I can reach my neighbor, something happened, I need to tell my other neighbors that link went down and things like that. You can tune those timers. Some people have. Not a good idea. Why it's not a good idea? Typical aggregation layer. You got like, what, 2 or 3 protocols, HSRP, PIM, OSPF, BGP. You try to tune all of them down, nightmare. I keep looking at customer configs. Oh my goodness. They have timers tuned everywhere. I don't know how they read it. I couldn't. Right? Maybe for those people who are used to their network, they can deal with that. But I couldn't deal with that. I told them, hey, can we simplify this stuff? They go, okay, yeah, we can. CPU utilization. Don't make the switch work too hard, right? Make it do useful things. Don't make it just send a bunch of hello packets. We have other useful features that the switch can do besides doing this. Right? ISSU, I said before with LACP. You tune timers below the default, no ISSU. Okay? And we can't do sub-second detection. We don't support fast hellos for OSPF, doing sub-second hellos, any of those things. Okay? Now, having said that, in some small environments, it can work. Right? We've validated a few cases without ISSU where people just said, you know what, I can't do anything else. I have to tune timers, right, for various reasons. But very, very much not recommended. So the question is, what do we do? Well, by now you've probably figured out is we use BFD. So BFD, bidirectional forwarding detection, we're getting to this now. It's a lightweight protocol that was designed to do a layer 3 failure detection. The way it works is we actually have a bunch of clients, OSPF, BGP, HSRP. They'll register to BFD. They get uniform detection capabilities. I don't have to worry about that, hey, I've tuned timers on one protocol, but then I have different values on another protocol. So this one converges faster, this one converges slower. How in the world do I troubleshoot a network like that? It's not going to work. So with BFD, we have one set of timers. We only rely on that for all of our clients. Okay? So that's pretty cool. And the one thing to remember is that out of all the features that we discussed today, this is the only mechanism that was designed from the ground up to do a sub-second detection. Okay? So keep this in mind. Why is BFD awesome? Okay, general advantages, right? I talked about reduced control plane usage, right? We just have one set of aggressive timers versus trying to tune all the protocols. We can do sub-second detection. We can negotiate timers in flight. What's up with that? Okay, so we use this to do ISSU. We can actually inflate timers in flight without tearing down the BFD session. We tell our neighbor saying, hey, can you increase your timeout to like 25-minute value? Let me upgrade my line card, and then I'll bring it back down. LACP cannot do that, by the way. Some people wanted to do that, but they can't. Okay? On the Nexus specifically, we have stay for restart. We have protocol offload. Remember I mentioned about scale. If you want scale for BFD in all of these ports, you can't run it on a centralized CPU. If you have a platform that does it, It's not going to scale to 700 ports or even to a couple hundred ports. It's tough. Switch got to do a lot of work. We have to distribute. We have to offload it down to the line cards. So we'll talk about that. Perlink. We'll cover the Perlink implementation. How do we do BFD with bundles? Again, not every platform can do that. For your reference, BFD operation modes. We have async, which is the initial BFD session establishment. And we also have echo, which is an additional capability where we send self-directed packets. We send it to our neighbor, and the neighbor loops them back in the hardware and sends it back to us. Allows us for some additional level of forwarding path verification. Okay. BFD and NXOS. By now, we have a pretty comprehensive support. So you got single hop BFD, right? There's no multi-hop. We have V4, we have V6. We just added the V6 support for the Nexus 9K. Okay, so that was probably one big thing outstanding. The Nexus 5K, 6K don't have it yet, but it's coming as well. Okay? So two things, centralized implementation for most platforms. For Nexus 7K, you have offload, and the Nexus 9500. And there's a few slight differences in how we do it between the two platforms. So the gentleman earlier asked me about, am I going to cover Nexus 9K? Yes, so we are talking about Nexus 9K for sure. We're not talking about ACI, but we're talking about any kind of standalone deployments. VPC, fabric path where it applies, standalone fabric, right, with a BGP overlay control plane. All right? Nexus 2Ks. Who's got Nexus 2Ks? Okay, so Nexus 2K doesn't support BFD. If you connect routers to Nexus 2K, which we can support with the Nexus 7K, so 2K connected to 7K and connect a router to a 2K, we can support that, but no BFD there. So we cannot run BFD on the 2K, we cannot offload it there, and we cannot send BFD packets through the 2K. Right? So if that's something that you're expecting and you're trying to configure it and the packets are not flowing, well, now you should know, right, that that's not going to work. Okay, so this is one of the reasons if you're trying to connect a router, maybe you want to think about connecting it to a real switch or connecting it to a parent port as opposed to connecting to FX. Okay? Sure. So the question, what about UCSFIs? They don't support. As far as I know, they don't support. Right, so about UCSFI. Okay. 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 Oh, okay. Okay. Okay, very good. Very good. So the gentleman here is more knowledgeable about UCS than myself. But okay, yes, I don't deal with UCS. Sorry. Yeah. Uh-huh. So the question is, can I do BFD between the 5K and 2K, but not after the 2K? Sure, sure. Okay, so after the 2K, no way. Right? Between the 5K and the 2K, hold your thought until the end of the session. Because as I mentioned to the gentleman earlier, I'm covering what do we do on the uplink between the 2K and the 5K. There's something running there. It's not BFD. It's not UDOD. There's something else. Okay? You will see. All right. Any more questions? Okay, good. BFD offload. As I mentioned, in order to achieve scale, we have to do offload. So we have a protocol, or we have a component that's running on the line card on the 9500 and on the 7K and 7700. It sends hello packets. The component on the supervisor, the SUP BFD, as you see on the above, it just takes care of the logistics, right? Having the clients register it, telling the line card BFD component saying, hey, bring me up a session. If the session goes down, line card BFD tells it, hey, the session went down. Go do something. Tell OSPF that their session went down, the one that they registered for. Okay? So we generate the hellos on the line card. We receive the hellos on the line card on both platforms. Okay? So again, we do that for scale. One additional thing that we do on the Nexus 7K platforms with the 3 line card. So the 3 line card has this capability, or has this chip called FSA, Fabric Services Accelerator. It allows us to do additional level of hardware offload, and allows us to bring the BFD timers from 50 millisecond to 15 millisecond. Okay? So first we do software offload. We just run it on the line card CPU. That's pretty good. but for some people it's not good enough. So we use a dedicated hardware for this. Okay, so we can bring the BFD timers down, and this is coming in NXOS 7.2 in maybe this week, maybe next week you should see it posted. Okay, so offload on both platforms, software float, additional hardware float on the 7K and 7700 with F3. Okay, so if you wanted to crank out all the possible timers, the ones of you who wanted the tightest possible SLA, this is like 15 millisecond interval times 3, 45 millisecond failure detection. Pretty good, right? So hopefully we'll be okay there. Bundles, I mentioned bundles a couple of times. We have a little challenge with the bundles. Two cases, layer 2 bundle, layer 3 bundles. Now, what do we do there? We typically send BFD packets on one link, and maybe it will hash return on the other link. But if I have 3 links, 4 links, 5 links, 6 links, not all the links will get tested. So what do? How can I make sure that all the links, the forwarding path gets verified? Remember, I'm still running LACP, but LACP is pretty slow. And you start talking to me about BFD, you told me about how awesome and fast it is, but now I have a problem. I'm not testing every single link. So you tell me to resort back to LACP? Well, hopefully not. Right? But in some cases, you may have to. And by the way, remember that with your protocols, your OSPF, BGP, or your layer 3 protocols, they do the same thing. They still get hashed in one single link. The only difference here is that I've kind of set an expectation here that with BFD, you should have a sub-second failure detection. Right? We don't have that expectation with the routing protocols to achieve sub-second failure detection. We shouldn't have that expectation. As I said, BFD is the only one that's been designed for sub-second failure detection. So what do? First thing that we can do is just the BFD logical mode. No, it does not test every single link in a bundle, but at least it will test some links. So it's still better than not running it at all. Okay? We have some additional mechanisms on the Nexus switches with the exception of 9K where we can spray the transmit packets on all the bundles. But the return packets, the echo packets, remember those packets that are self-directed, they come back to me. I send them to my neighbor, they come back to me. Those will still get hashed on one link. Okay? This is better than just running a protocol, better than tune-in timers, but it does not guarantee a sub-second failure detection on every single link. Right? So there's still a little bit of a hole there. Next option, there's a fewer amount of platforms that support this, but we have a proprietary BFD per link mode. Proprietary means it only works between Nexus. Connect an iOS switch will not work. Connect CRS will not work. Only works between the 2 Nexus switches. So what we do here is now we can run a BFD session on each individual link. So I have a little bit more assurance that each link will be tested for a failure detection. Okay? And I can run 50 millisecond timers there and do those things. Yes, sir?
Is this global or like if I configure, is it a global thing that I have to have all Nexus 5, 6, 7, 9s, or
Sure.
can I configure it per link? Do we have other things connected?
Yes, yes. So the question is this configuration global or is it per bundle, right? Yeah, no, you can do it per bundle. You don't have to do it on every single bundle because we completely understand that. In some cases you can, and in some cases you cannot use this. Right? Otherwise, this would be completely unusable. Yes. So, good. Yes? So the question is, can you use this on the VPC peer link? On the layer 2 links, because VPC peer link is layer 2. And the case where we have 2 SVIs, BFD over layer 2 peer link, cannot. So this is only on layer 3 bundles. Okay? Yeah, very good. Okay, I should clarify that. Yeah, only layer 3 bundles. Any more? Okay. So that's per link. So what do we do now? How do we do interop for this? Because we clearly have an interop challenge, not just Cisco to non-Cisco, but within Cisco. Okay. So right now, you do single session. This is the easiest way to achieve interoperability. We've verified it across different platforms. We've verified with some non-Cisco devices. Again, better than nothing, but not good enough. Wherever you can, use per link. If you have Nexus to Nexus, you can do it. CRS, ASR9K, by the way, they have their own version of per link as well. So between two XR devices, you can do that as well. But again, not compatible with Nexus. What is the solution for all this stuff? RFC 7130. It's been ratified about February last year. So now it explains how you're supposed to do this. Because before, original BFD standards did not explain that. So every vendor did their own thing because we had to solve a problem. Much like when we started with UDOD. There is no standard. We needed to give a solution to the customer. Okay? So as you start seeing vendors and different Cisco routers and switches implement this, so be on the lookout for that. Okay? So that's BFD and bundles. Those of you who are running Fabric Path, we're moving to Fabric Path discussion, BFD for Fabric Path. Here's where we use Fabric Path ISIS as a client for BFD. This is like the first time when you have a layer 2 network and actually have a sub-second failure detection protocol in the layer 2 network. Because before, all I had was spanning tree bridge assurance, UDOD, LACP, nothing else. So with Fabric Path, I have something a little bit better. Okay? So if we have two Fabric Path switches, and if I have, for example, an optical system in between, I can detect that unidirectional failure faster. It's already shipping on the 5K, 6K. It's about to come on the 7K, 7700 in an XOS 7.2. If you're lucky this week, maybe next week. Okay. Right, so there's a couple of additional notes for your reference there with respect to how the layer 2 BFD works in the Nexus platforms. And here's an example, right? What you'll see here, we don't have IP addresses. We have MAC addresses. This is two Fabric Path switch IDs that are trying to establish a BFD session. Okay? So where this applies mostly, remember I said that if you got point-to-point links, may not need to do anything. Remember, I say may not, because there's always corner cases. There's always customers who have faced an issue and they said, you know what, I need to have the maximum level of protection, and that's okay. Right? What I want you to do is understand what is likely to happen and what is not likely to happen, or less likely to happen. Okay? But in this case, back to our bump in the wire. I have an optical system in between. Some people use Fabric Path to interconnect multiple data centers. No, this is not data center interconnect. What is the primary technology that we use for data center interconnect? It's OTV. But for some people, they just want to stretch a fabric. They have the data center in one building and another building. They don't need all this isolation. Right? They just need to have a stretch fabric, and this is what Fabric Path provides for them. But in this case, layer 2 BFD can apply quite well. Right? So in this particular links where we have optical systems in the middle. All right, now we're getting more complicated. BFD over Fabric Path. Remember I said Fabric Path is a pure layer 2 network. It's one big switch. What do you do if you want to do layer 3? Well, you run routing protocols on top of Fabric Path. Yeah, you can do that. In some cases, the rightmost case is supported in all platforms. The leftmost case, Nexus 7K doesn't have it yet, but it's coming in XOS 7.2. Essentially, if I have a Fabric Path switch, if I have an SVI on that switch, and I want to run a BFD session from that SVI to another SVI, and the BFD packets are exiting on the Fabric Path core port, will not work on the 7K right now, but should work in the coming week. Okay? Now, some people have done this. They've tried to create those type of designs, and they haven't accounted for something like this. So you got two routers, kind of routers on a stick hanging off a Fabric Path network, doing HSRP. I don't have VPC+, I don't have Anycast HSRP, none of those other things. So I need to have a failure detection protocol or mechanism for HSRP. Remember I said if it's active-active, you don't do anything. But here it's not active-active. Okay, so I can send BFD packets through the fabric. But here's what happens. How do we forward multicast packets? HSRP uses multicast. How do we forward multicast packets on the Fabric Path network? We use multi-destination trees. So multicast packets may go this way. BFD is unicast. BFD can go this way. So you're not really testing the forwarding path. You're not testing the same path here. And you may have to tune the timers. You may have to tweak them upwards to allow for Fabric Path network to reconverge. Okay? So you can do all those things. You can try to design around this. Or you can evolve the fabric path network to a standalone fabric, right? Where we have an integrated layer 2 and layer 3 solution, where we have a BGP running there. You don't need to run routing protocols on top of the network. Okay? Speaking of standalone fabric, right? Before it was based on fabric path. Here it's based on layer 3 with VXLAN. One functionality that we're about to bring the support for on the 7K, it's already there on the 5K, 6K, is the BFD for IP unnumbered. How many of you have heard about IP unnumbered? Okay, those folks who are coming maybe from service provider world, SP folks love it. Remember I said about what can apply from the SP world? This can. So instead of running IP addresses on each of the individual links in the fabric, as your fabric grows, you need a lot of IP addresses. We can just use loopback, and we can peer BFD using the loopback interfaces and put IP unnumbered on the interface. So for your reference, this is the config. This is about to come as well. So this is part of the standalone fabric solution, but it can also be used individually. If you have a big layer 3 network and you want to save on IP addresses. Right? So BFD can work there as well between the two loopback interfaces. BFD for OTV. Who uses OTV? Got a few hands. Very good. So for OTV, what we've introduced is ability to detect a failure between two authoritative edge devices. With OTV, we use dual or hardened multi-homing. We have OTV peering on the overlay, and we have OTV peering on the site VLAN. So the site VLAN, we can detect sub 150 milliseconds. We use BFD for that. The overlay, we have to use a next hop notification, right? Route reachability. If the route to my peer goes down on the overlay, then I can bring it down. So no, I do not have an end-to-end detection here for 150 milliseconds, but it's a heck of a lot better than waiting for ISIS timers to expire, which is what we used to do before. Now, in the future, when we support multi-hop BFD, maybe we can do something better on the overlay, and we can bring the total failure detection down to below 150 milliseconds. But today, it's, again, better than 40 seconds, but it's not quite 150 milliseconds. Just to make sure I set your expectation correctly. Okay? Static routes might be a scenario that you'll have. Firewall, transparent firewall in the middle, you got static routes going. What do? You can use BFD for static routes. Actually allows you to remove the static route when the BFD session goes down. It only brings back the static route when the BFD session goes in. Remember, right, it's static. There's no hellos, there's no protocol there, so this is the only thing you can do to account for an indirect failure. Now, you could have a layer 3 bump in the wire, a NAT device or routed firewall. If you got static route there, well, you'll need BFD multi-hop. Okay, so similar kind of behavior. We have this thing on iOS, we have this on XR. Unfortunately, we don't have it on Nexus today. So if you got Nexus and you have this case, what do? Well, the solution that we have right now is IPSLA. Okay, so we can use IPSLA to track static routes and to track PBR. Now, IPSLA is no BFD. It's not sub-second. This is just ICMP messages going from the supervisor. But it's better than having nothing. Right? It's better than just having static routes and have a black hole. It's better than just having PBR and have a black hole. Okay? So we can use IPSLA here for tracking. So if I have one of the PBR paths fails, we can reconverge. Typically, we can set IPSLA interval to 1 second. We can have a detection of 3 seconds. Okay? Yes? Sure, so the question is, can you use a combination? I would say that in a case where you can support BFD, like if you're running a routing protocol there, then why would you? This is the case of, back to my scenario of simplicity. If you think that you need the extra protection, maybe you can. I usually prefer to keep things simple, right? This is debatable, right? This is my opinion. Right? BFD should cover the indirect failure scenario, so you can use BFD there if you have a routing protocol. If not, then IPSLA is your only choice. Does it work, both of them together? Yes, it does, of course. Right? Should you do it? We can debate on that. Right? Okay? Right? All right, so we'll reconverge. We'll start sending traffic again. So best practices for layer 3 failure detection. As I mentioned maybe 100 times before, use BFD, right, wherever you can. If you can't use BFD, you have to check on aggressive timer support. And you have to plan your BFD scale. You want to run BFD on all these ports? Well, you got to have a switch that can actually support this. Some switches do, some switches do not. And you should check, how does that switch actually support it? Does it do offload, or does it run all those sessions on a supervisor? We have seen from customers, if you have all those sessions run on a supervisor, up there, no good. It doesn't scale, it doesn't work. Definitely doesn't work if you're trying to do 50 millisecond interval or below. Right? It's one CPU that's doing all those other things. OSPF, VDCs, BGP, OTV, and you make it work and do BFD. Right? So that's why on the larger modular platforms we do offload. On the fixed platforms, it's always centralized. Okay? BFD echo, I mentioned about BFD echo once, right? The self-directed BFD packets that allows us to have additional failure detection, additional forwarding path testing. Okay? And bundles, right, wherever you can use per link. If you cannot, you still have an option to have at least BFD running there, but maybe it will not be testing every single link. In those cases, LACP will take care of the ones that are not being tested. Right? So you still have something. You don't have a complete black hole. Okay? So few folks ask about FEX. We're coming to the FEX real soon. But before that, additional mechanisms. First one is RISE. How many of you have heard about RISE? Okay, great. There's a RISE session that's happening in parallel. But we can talk more about RISE after the session. There's a product manager for RISE that's sitting in the room. Okay? So great technology allows us to pair a service as appliance to a Nexus switch. Make it look like a module inside the Nexus switch. What does this allow us to do? Well, if we're trying to redirect traffic to an appliance, typically we would do PBR. If it's a one-hour mode services appliance, a load balancer. What this can do is I can create a virtual server, a VIP, on the appliance. The appliance will actually use the RISE protocol to push appropriate configuration to the switch. Okay, so it would allow us to redirect the traffic and no network guy intervention. So on the power of the load balancer guy, because the load balancer guy would know what is my virtual server, what are my real servers, and how I want the traffic to be redirected. Right, so I push PBR entries down to the switch. Now, how do I detect an indirect failure in those links? Right, we can do home and appliance, we can use VPC. Unfortunately, this is one case where we don't do LACP. Right, so normally in all VPCs we run LACP. Here we don't run LACP. Here we have a proprietary protocol that takes care of that failure detection. It actually does it a little bit faster than LACP. Okay? But just so you know, right, there's nothing for you to configure aside from the RISE feature itself. There's something that's already running there. If you're seeing complete black hole, well, that's unexpected. You should call TAC. Okay? FEXes. Okay, two folks asked about FEXes. On the links, on the uplinks from FEX to a parent switch, whether it's 5K or 7K or 6K or 9K, we're running this thing called Satellite Discovery Protocol. Right, so it has its own interval, keep alive 3 seconds, sub 30-second failure detection. So there's no BFD there, there is no UDOD, there's none of those things, but there is something there that's running to protect you from a complete black hole. Okay? Does this answer the question about the FEX for a few folks? I think you asked the question about the FEX. Okay? Good? Excellent. So we're at a wrap. Yes?
What about dual home FEXes?
So the question is, what about dual home FEXes?
Yeah, 2 5Ks.
Same thing.
We've had an issue with port errors.
Port errors. Okay.
Not enough to bring the links down.
Yes, yes. Okay. So the question is, well, what about dual home FEXes connected to 5K? I had some port errors that was not enough to bring the link down, but it was kind of affecting, degraded your service. So what I would say, first thing, dual home FEX only on the 5K, 6K, not supported on the 7K yet until NXOS 7.2, which should come, as I said, this week or next week. That's one thing. Now, you're right. The existing mechanisms, the satellite discovery protocol, it tests the link, but it may not be enough to bring the link down based on degradation. What do you do today? Typically, folks have scripts. They poll, they use the EM. If the number of errors goes above the threshold, we can bring down the link. What I'm hoping for is that when we have the link OEM functionality to do the link monitoring, we can actually take care of this case as well, right? But today, yes, you have to do a little bit of manual work if you really want to protect against that condition, right? So not enough to bring the link down, but still affecting your traffic. Does that make sense? Okay, very good. So, summary of recommendations. We've talked about all of these scenarios. I have a few minutes left. Classical Ethernet, point-to-point links or bundles. Remember, we have LACP, we have bridge assurance. For most scenarios, they will take care of all the indirect failures. Fabric path, point-to-point links, bundles. We already have a bidirectional protocol there. Oh, and guess what? Now we have BFD too. And there's LACP running there if it's a bundle. Okay, so you have plenty of stuff there. Common question, do I need to run UDOD on my Fabric Path Core ports? The answer is no, right? Unless you can think of some of the miswiring scenarios that we discussed earlier, right? That a few folks in the room raised their hand for. Okay. Layer 3, well, the answer should be obvious by now. Use BFD. We've talked about this quite a bit, right? In any case where this applies, especially where you have a bump in the wire, right? A switch, a transparent firewall in the middle, all those different things, use BFD. Okay? So what have we learned? We talked about failure detection, which is the key to fast convergence. Right? You can't be thinking about designing a network for faster convergence before looking into this. So you come to the session first, you read the slides, then you can think about tuning your SPF timers, then you can think about prefix-independent convergence, not the other way around. Okay? You have to match your requirements to the right set of technologies. If you have very tight SLA, maybe you need to use everything that we've discussed. If you're a little bit looser, those of you who are like, okay, I can detect a failure in 1 minute, maybe you don't need to do anything at all. Maybe it's all, everything is built in. Okay? As I said, right, I'm about simplicity. So in my opinion, if one protocol can do the job, one protocol is enough. But we may agree to disagree that you may want to have additional mechanisms for safety, right? This is more of maybe, okay, I really feel that this link is super critical. I want to have another mechanism, right? So that is possible. Support it, yes. Do I like it? Not my favorite thing, okay? Finally, we looked at evolution. We saw that there's still some problems to be solved, right? Particularly BFD on bundles, right? So this is an evolving field with some new Cisco innovations, such as the layer 2 BFD, and industry things, right? RFC 7130, which does the BFD per link, which is now a standard, okay? So what I would encourage you to do is design your network by taking advantage of all these best practices and be on the lookout for how the industry evolves with failure detection. So a couple of related sessions, they're all completed for the week, but recordings will be there. So router fast convergence talks about the entire fast convergence. More details on link OEM, right? There's a whole session on that and a few other things. Okay, so you can see the recording for this. You guys heard about my favorite speaker? Okay, so if you like me, if you think that I'm your favorite speaker, there's my Twitter handle. You can vote for me. I would appreciate that. What I would appreciate even more is if you submit your evals and not just give me the scores. 5s are good. 5s is the best. 1 is the worst. Sometimes people get confused. Believe me. They go like, oh, I thought 1 is the best. Right? No, 5 is the best. But not just your scores. What I really like to see is your comments. Was it good information? Was it useful for you? Would you like to see something else? Right? We always try to adjust and improve the sessions. We read every single comment and every single feedback. So I really would appreciate if you give me some feedback and things to improve, things that went well for you. Okay? And with that, have a great rest of the day at CiscoLive. Thank you.